Yeah, hello to the second episode of Tips and Tricks and Little Hacks that every C programmer should know. Today we talk about a way to measure the execution time of your program, more precisely, even a single function of your program. And with that, welcome to myCTalkthroughs. So let's have a look at this example here, where you can see that I just created a very simple job, which basically counts from 1 to 1,000,000 and prints a dot on the screen. So it prints 1,000,000 dots on the screen, but we get here some execution time, at least on my system. But first, we don't want to know, we do not know exactly what and how this execution time is measured. And second, let's assume that our job here does not run in the main function. So our main function is maybe not the main function, but some kind of sub-function doing some boring side job we need to measure the exact time for. So what we want to do here is we want to measure the time, the execution time between this moment here, line 6 begin, and line 13 close. While close is not a good term for that, let's say call it stop, like a stop clock. Yeah, when it comes to time measuring, we can make use of clock underline t. That's a struct defined in the header time.h, and there we create us stop m and start m and stop m for time measuring. So far so good. And yeah, as you can see here, I already put in here some macros. And now it's time to define exactly that macros. Yeah, let's start with our begin time measuring macro. For that, I put in this here. So don't be confused by the backslashes here. They only serve us to divide the line here. It has totally no influence on the text which is exchanged for the term begin here at all. So what we do here is we just start the clock. We just define that start m will assign some value, the actual value exactly in this moment of returning from the clock function. And if that failed for any reason, so if we get a result of -1, in that case, we just print out an error and leave the program. So what starts needs also to come to an end, and that is very similar. We also create us a macro stop here, and that does exactly the same thing. It just stores the time at the actual point in stop m, and if that fails, it also returns an error and exits. So that comes into my mind that it could look at least the same way here with the backslash. Then it's some more visible what is going on here. Afterwards, we also want to output our time measuring, our result. And that result is pretty simple calculated. We just output a float, a double to be exactly here, of stop m minus start m. So the stop time minus the start time, and that we divide through clocks per second, because that is a number of, let's call it, ticks of our clock, which is measured and defined in time.h. That is how you usually define the whole thing. Now let's test our little program here. So, as you can see here, it shows us that between begin and end, our program took 0.026, so 26 thousandths of a second to run. The execution time here shows it run approximately 5 times longer, but we can be sure in our little program that between begin and stop and running this task here, the exact time of second run 0.027 seconds elapsed. Yeah, I think that is a nice little trick here, which you can recycle just by using these macros within your code at any place. And as always, you can find a link to the code repository in the description of this video. Thanks for watching. Please give it a thumbs up, hit the subscribe button and the bell. I hope to see you for the next episode of myCTalkthroughs.